So I know you guys had ऐसा बहुत कुछ ज़्यादा एकदम technical in-depth knowledge, and to be honest, even I myself had like ऐसा nostalgia where I was just remembering the first time when I was learning all of these things, and to be honest, these were at the very first time very overwhelming to me. But these guys, the trainers which you are being seeing and listening to since past 4 days, have really broken it down into very small things, and they have explained it really well. So that's a great thing. Like these people are just from second year and third year, and that's a really great thing to teach with such a great easiness and all. So now we'll be having this a very chota topic at the end of the session. Like it's the dynamic memory allocation. So right, till now you must be facing a kind of curiosity कि अच्छा ये सब code we are compiling, that's great and all, but ये code आखिर store होता कहाँ पे है? Like if yeah, of course it's getting stored in the RAM, but वो RAM में कैसे store होगा? Is there some data structure, or is there any particular format जिसमें ये सब चीजें, the code which we write, the functions which we write, the variables which we declared, ये सब, is there some sort of a well formatted or well sorted way जिसमें ये सब चीजें रखी गई है, या फिर it's all just ऐसा पूरा randomness and it's all anarchy in there? लाइक कहीं पे भी कोई भी फंक्शन ऐसा घूम रहा है मेमोरी में, वेरिएबल कहीं तो तीसरी जगह डिक्लेयर्ड है, फंक्शन कहीं तो चौथी जगह डिक्लेयर्ड है, एंड इट्स ऑल मेस. So now we'll be getting it in thoda sa depth with these particular topic. That's the dynamic memory allocation, and in general how these things work out. So basically, there are two types of memories when we are talking about the memory structure. The first is stack and the second is heap. So now let's discuss about the first one, which is stack. Okay, now let's consider a sample program. Like, don't worry, all of these programs will be shared later on, and the reason why I'm not showing it this particular thing on the compiler is because the main intent of this program is to show you how the memory is getting utilized and not what the output is. So let's consider this program. So basically we have our three main functions. This is the main function, wherein it's the main function wherein we'll call all the variables, utilize all the parameters and stuff like that. This is the area of the square function. So basically we are going to calculate the area of a particular given square. And this function is the function which returns the square of a number. So as we know, the area of the square is L square, like side one square. Any of the side uska square, that's the area of a square. So yeah, basically these are the three main functions. And then we have this particular global variable defined over here. So abhi tak jo, like you guys must be knowing कि global variable is a variable which we can access throughout the function. Like कहीं से भी access कर सकते throughout the program. Sorry, कहीं से भी access कर सकते उसे. So now let's discuss कि आखिर इसकी memory allocate कैसी होती है RAM में. The first thing which gets allocated is a global variable. So let's say कि let's have a different color for this. Yeah, the global variable somewhat ऐसा उसको आराम से एक जगह पड़ा रहता है वो. Let's name this block as global. And then what happens is ये जो बाकी के functions है, these all get allocated in a form of stack. Stack मतलब have you ever be like किसी के घर पे कोई ऐसा books रखे रहता है क्या? Like a pile of books, right? That's a perfect example of stack. So the most recent book which we keep in is the latest one which we keep in would be the first one we'll be taking out from the book. Or a pack of Pringles वो पता है ना, वो बड़ी से cylindrical rod में carton में वो chips आते हैं. That would be a perfect example of stack. Like it's sort of in first in last out structure जहाँ पे like latest वाला जो structure latest वाला जो object अपन रख रहे हैं, it might be book or something. So वही वाला अपन सबसे पहले निकाल रहे हैं. So that is a stack. So basically something which we saw in PPT. So this is a stack. यहाँ पे अपन कोई तो एक add कर रहा है, कोई will add one burg over here, and then we'll pop it out. So this is how a stack works. Now, what happens is when the stack data, the stack memory stack, it gets allocated in like in the runtime and whilst the code is compiling. So uske pehle beforehand we know as it's getting allocated in the compile time, we know what all the variables we are going to use, its exact memory requirement. So for example, the int main which we are going to use here will be stored something like this. This is the whole stack. I'm sorry because the straight lines, I'm not really great at drawing. So yeah. So what will happen is the int main will be stored in the very bottommost form of the whole stack. So let's call it as a main thing. And the memory which will be it will be consuming would be predefined. मतलब उसका अपन and it's unalterable because we are not defining anything new or anything ऐसा कुछ अलग नहीं define कर रहे throughout the runtime. So it's unchangeable. उसके बाद आएगा this thing int area of the square वाला function. So let's put it in short as AOS. And then the last function will be the square of number. So SON. So now what happens in the memory is कि अभी ये जो सबसे ऊपर वाला stack में जो function है, it will be playing या फिर it will be getting executed. So I'm so sorry for this. So yeah. So it's playing. And उसके बाद until then everything down here is paused. मतलब जब ये function का call होगा, suppose now I'm in the main function. Now main function encounters this particular thing, area of the square wala function. Now this function will be stopped. The main function will be paused for a while, and this area of the square wala function will be being played or being executed. Now this area of square wala function then again calls in turn the square of numbers wala function. So again we'll be playing this square of number function, and until then the area of square function will be paused. Okay. So पहले now if the like अगर the sum of number function gets executed, like it gets executed without an error or it gets executed, then it will return. So now this will be popped off from the stack. Now what will be running is the area of square wala function. After its successful execution, lastly we'll go to the main and it will be executed and then cleared off. So this is how a stack data structure works in the RAM or in these particular things when you're compiling the code or when you're running the code. And at the very end of the program, these global variables the space which is allocated for global variables will also be deleted. But there are a few drawbacks for this particular stack, or a few limitations, that would be a precise word. So for example, we write some recursive code, as we all know, we have discussed recursion earlier as well. So if we write a recursive code without an exit statement, like without a break statement or return statement, then what will happen is our stack, so this is again the main, and then we'll be just putting in more functions into the stack until it gets filled up. So the moment our stack gets filled up, then our program crashes and we go into a state known as stack overflow. It has nothing to do with the website, and the website also doesn't have to do with any of these errors. But yeah, so if we just put on more and more functions in the stack without a recursive code with no end, and then we'll be just overflowing the stack, and eventually our program will get crashed. So this is something you have to be careful with. But yeah, and then the next part is about the heap data structure. So what if we are dealing with some sort of program where we do not exactly know what will be the name of our what will be the number of data structures we'll be needing, or what will be the number of variables we'll be needing. For example, we are inputting a name, taking in a name. So a name can be a very few letters long, such as some 4-letter word, जैसे कि Yash. Yash का name is only 4 letters long. While if you take mine, I guess it's yeah, my name is around 7 letters long. So you cannot have a particular predefined structure कि जहाँ पे size of an array कि जहाँ पे it's like कि अच्छा नाम है तो सिर्फ 10 variables का ही 10 length का ही 10 characters का ही रहेगा और या फिर yeah something like that. So for such kind of scenarios, we need a dynamic allocation of memories. So what happens is this thing known as heap. So in heap, it just let's clear on this particular point. It has nothing to do with the data structure heap. It's just a coincidence that in दोनों के नाम are just heaps and all. So what happens in a heap is everything is randomly allocated. Like everything is जैसे कि हमने पहले डिस्कस किया. Everything is in total anarchy. कोई भी चीज कहीं पे भी एक like everything is all messed up. So when we allocate something dynamically, or when we need some data, some sort of data segment or fragment at the runtime, so we call this particular memory from that heap data structure. Oh, sorry, heap memory. So like if we need some sort of variables, we have this particular main ka stack over here again. And if at runtime we need some p variable, so we can declare this p variable and then we can point a heap memory. So this memory will be allocated temporarily, and it will be freed at the end of your program. But it's always suggestible कि you free your memory on your own. Like if you're allocating some memory, just make sure you're freeing that particular variable or that particular memory location. Else it would be just be there allocated and just wasting the whole memory. And if this gets over a limit, then again your program will crash and it might harm your operating system for a while as well. Like earlier, in earlier scenarios where people were not too much educated in terms of cybersecurity, these were some of the attacks used, like Stack Overflow attack and things like that, to halt your entire process or to halt your entire CPU. Now the question comes, yeah, we need some variables which to be dynamically allocated at runtime. So how can we get those? So in C++, we have two operators. First is new operator, through which we can get new memory, allocate new memory in our project. And the second is delete operator. And delete, as the name suggests, it memory and deletes the whole thing. As I said earlier, if you are allocating the memory in your project, then just make sure ki you're deleting it as well. Now let's discuss a few examples. For integer or for any particular data type, we can follow this particular syntax and then allocate memory dynamically. The first thing would be declaring the pointer variable. So, and then declaring this particular data type the space to it after the keyword new. There is like as we discussed in this particular scenario, yeah, we need an integer pointer to point at this particular memory location. Like if we fail to do so, or if we reallocate this particular thing to some other memory location, this part of memory is just lost. And then if we like a similar case goes with implementation of arrays as well. So if, as in the example, we are allocating 10 integers, sorry, the memory size is equivalent to 10 integers for the pointer p. Then what will happen is we'll have these particular 10 blocks, 1, 2, and until 10, allocated after this particular pointer. So in short, we are just declaring the array of 10 elements using the new keyword. And for delete, as we spoke earlier, the delete keyword, we are just to mention the keyword delete and the variable which has to be freed. This can also be implemented for objects, like we have to just define the class pointer and object pointer. and then use the keyword new and define the object which is to be created.